Hey guys, what is up everyone? How are you people doing? Welcome back to today's session. Welcome to a brand new chapter. We'll be starting off with refraction of light at plane surfaces. This is for ICSE 10th. A very warm welcome to all of you guys out there. My name is Anup and I'm a master teacher of science here at Vedantu. Once again, hoping that you guys are doing good and taking good care of yourself. So without any further delay guys, let us get into the topic for today. Today we'll be understanding about refraction of light, the basic concept behind refraction of light. What exactly is refraction? What is the reason for refraction to happen? All of that is what we're going to be looking at in today's session. So before we get started, as always, we have a quote for you people, and the quote for today is this: you are only confined by the walls you build yourself. There's no other statement which can explain this better. You are the only limit that you have. Whatever is your limitation, it is something that is set by you subconsciously or consciously by yourself. So remove that wall, break that wall, so that you can move forward and expand your knowledge and reach out to greater heights. So please guys, make sure that you keep an open mind and never subconsciously build a wall around yourself and restrict your own growth. All right, so with that said guys, let us get started with today's session. So these are the concepts that we'll be looking at in the sessions ahead. Today we'll be talking about refraction of light, then we'll understand about the laws of refraction and refractive index, the factors affecting refraction and principle of reversibility, refraction through a prism, and factors affecting the angle of deviation. We'll talk about the real and apparent depth, the critical angle, total internal reflection, and total internal reflection through a prism as well. So these are the concepts that we'll be looking at as we go ahead. So I hope you guys are going to stay with us in the sessions ahead as well, so that you are able to keep yourself aware of what's happening in the sessions day by day. Alright guys, with that said, let's get started with today's session. That is nothing but refraction. Let me just start off with defining refraction. What is refraction? Is nothing but the bending of a ray of light when it's passing from one medium to another. That is what is called refraction. Now when I say medium, it can be air, it can be water, it can be glass, whatever that is. So when light is passing from one medium to another, it bends or it deviates a little from its original path. That bending of light is what is called as refraction. Now it's not a new concept, all right? New refraction is definitely not a new concept. You would have probably noticed this several times around you. Maybe you would have not paid attention to it, but the next time you see it, do understand that this is the reason for it. So for example, when you put a straw in a beaker containing water, or a clear glass, a transparent glass, you see that when you put it in, you see that the straw apparently looks a little bent. You can try this today. Take a glass, pour some water into it, take a pencil and put that pencil into it. It appears like suddenly, magically, the pencil appears like it is bent. But is it actually bent? No, it is not. But it appears to be bent. That phenomena that leads to you thinking that the pencil has got bent or the straw has got bent, that, my friends, is what is called as refraction. Now, for refraction to happen, guys, this is what happens basically. So imagine you put a pencil inside a beaker. So what is happening? Imagine that there's a ray of light. There are two rays of light. Let's say that it's starting from this point, one of the edges of the pencil, and it's reaching your eyes. But as it is passing from water to air, at that junction or at the place where the two mediums are separated, the ray of light starts bending. And because of that bending, what happens? The rays of light would reach your eyes. Instead of the ray of light going this way, it would actually take this path that you see over here. So what happens is that your brain always has this curiosity that where is the light coming from. So what it'll try to do, it'll try to trace back that steps, or it'll try to trace back where that light is coming from. And when it does that, when your eyes is starting to trace back the light, apparently instead of meeting over here, what happens is that the rays of light would apparently meet at this point. Now this point is where this is why you see that because of this reason you're able to see that the pencil has become bent. Now here's the thing guys, this apparent position of the pencil is called as the image, or there is an image formed because of the bending of light. And this image is not the actual, it's not a real image, it's a virtual image. It's not like, it's not something that that the object is actually bending. No, it appears like it's bending. It's just an illusion, it's just a trick to which basically happens because of this phenomena of refraction. It is not that the pencil is actually bending, but it's because of this reason, because the rays of light are bending. When you trace back the steps, it appears like it's starting from another point rather than where it is actually from. This, my friends, is what is called as refraction. Now, I'm pretty sure that many of you guys would have had this question: sir, why does refraction happen? Yeah, is that the water is a magical water? Like, you have to climb up to the Himalayas and get a bucket of this water, make sure it is, it's in ice state, and then bring it back over here and melt it. That is how you're going to get it? Definitely not. The reason why refraction happens is, guys, is because light travels with different speed in different mediums, or light has different speeds in different medium. So for example, in vacuum, the speed of light is 3 lakh kilometer per second. In air, the speed of light is 2 lakh 99,000 kilometer per second. In ice, the speed of light is 2 lakh 29,000 kilometer per second. In water, it's 2 lakh 25,000 meter per second. And in glass, it's 1 lakh 97,000 kilometer per second. So obviously, light is having different speeds at different medium. And because of this reason, what happens is that the bending of light happens, because the restriction, or for example, if you talk about a denser medium, like for example glass, which has high density, what is happening? The restriction is more. So what is happening? The speed of light actually reduces when the light enters into glass. Now here's the thing, guys. Here's what it would actually look like. So let's say that there's a ray of light coming and falling from air into water. The ray of light slightly bends. Why does it bend? Because the speed of light in air is different compared to that of water. If you just look at the value, the speed of light in air is 2 lakh 99,000 kilometer per second, whereas the speed of light in water is 2 lakh 25,000 kilometer per second. There's a very big difference. And because of this reason, there is bending of light happening. Now guys, what you have to understand is this: when the ray of light is traveling in high speed, when it's going at high speed, then it reduces the speed, or when it slows down, what happens is that the ray of light apparently bends towards the normal. So let me just give you the terms first. First of all, you guys already know about the incident ray. The ray of light that is coming and falling onto the surface of separation, that is the incident ray. The normal is what? The same thing that you've studied in the reflection chapter. You know what is normal. Normal is nothing but a perpendicular line which makes an angle of 90 degrees to that surface. That is what is the normal. And then you have the refracted ray, which basically passes through that particular transparent medium. Now here's the thing, guys. When the speed of light is high and then it slows down, the light ray bends towards the normal. Now what do I mean by this? Here's the thing, guys. The speed of light is going to be higher when the medium is rarer, when the density of the medium is less. Well, on the other hand, when the medium the density of the medium is more, then the speed of light is going to be slow. So, for example, if you talk about air and glass, air is a rarer medium. Glass is a denser medium. So when a ray of light is passing from a rarer medium to denser medium, the ray of light goes towards the normal. It is passing, or it'll try to go towards normal. But there's a clear, there's a clear deviation from its original path. This is supposed to be the actual path. But then what's happening? Because of refraction, the light ray takes another path, and that path that it's taking is actually towards the normal. Now what would happen? The same ray of light will come and incident on the basically the other surface, right? Now what happened? It'll go and hit over here. Now this is the surface where the refraction happens. So over here, this would become the incident ray, this would be the normal, and this would be the the refracted ray, or we call it as the emergent ray. So over here what is happening is that the light is now traveling from glass into air. So when the ray of light is passing from a denser medium to a rarer medium, the ray of light actually moves away from the normal. From rarer to denser, it moves towards the normal. Like from air to glass, it moves towards the normal. From glass to air, when the ray of light is passing from a denser medium to a rarer medium, the ray of light passes away from the normal. You see this? This is the normal and it's going away from it. Now, this ray of light that is passing out is called as the emergent ray. It is emerging out of that glass slab, and that's why it's called as the emergent ray. Now, the thing about emergent ray is that it is going to be parallel to this incident ray. I don't know if you have noticed this. If I extend this, those two lines, the incident ray and the emergent ray, are going to be parallel to each other. But yes, there's a big difference in the path. Obviously, it's not taking the same path. So there is a shift of that ray of light that is happening, which can be clearly seen when a ray of light is emerging out of a glass slab. As simple as that. That's it, people. So that is the basic stuff about your refraction. Now that you've understood this, guys, one more important thing, I'll just repeat it one more time. Listen to me very, very carefully. That's a very important factor, that when the ray of light is passing from rarer medium to denser medium, the ray of light would move towards the normal. When the ray of light is moving from the denser medium to the rarer medium, the ray of light would move away from the normal. And that is very, very important. Don't get confused. It's a very, very important part of your your syllabus, so make sure that you remember it. One more thing about the ray of light is this, guys. If the ray of light is incidenting exactly at 90 degrees, that is at normal itself, that is, if it is hitting normally to the surface, then the ray of light would pass undeviated. That means that there will be no deviation, no deviation whatsoever. It will pass straight through without any refraction. Because see, guys, the ray of light is passing straight. That is, when it's moving when it's hitting the surface exactly in 90 degrees, the ray of light goes undeviated without any sort of deviation, and it passes straight through into that glass slab without any deviation. So in conclusion, guys, what do we see so far? When a light ray goes from rarer to denser medium, it bends towards the normal. When the ray of light is moving from denser to rarer medium, the ray of light moves away from the normal. And when the ray of light incidents normally on the surface of separation, then the ray of light passes undeviated without whatsoever affecting, even if it is even if it's slowing down, that does not really matter much, because the ray of light is passing straight through that glass slab. As simple as that. Now that you understand, guys, let us get into the questions and answers. But before we get into the question and answer, guys, just give me 2 minutes of your time. It's going to be super important. Just give me 2 minutes of your time to explain something that would definitely help you guys in the future. So here's the thing, guys. We have done a survey about what are the problems that you guys are facing, especially during this pandemic. Like, what are the problems that you guys are facing on a regular basis regarding your studies and everything that is going on out there. So these are the problems that you guys came up with, and I totally agree with these problems. I'm pretty sure that there are more than these as well, but these are few things that you would definitely be able to agree with me. The first problem that majority of you face is that, sir, my doubts are not getting clear. You guys are starting from so many different kinds of YouTube channels and websites and stuff, but then your doubts are not getting cleared. Although there are a lot of websites which solve your doubts, it takes a lot of time for them to do so. Secondly, your notes, you don't get enough notes to practice and to revise what all you've seen in the online sessions. Tests and assignments, because you can't just go and write your exams. That is something that is bizarre. You can't just do that. You have to practice. So where do I get myself those tests and assignments to practice those questions and answers? Competitive exams, because I'm pretty sure that all of you guys are planning to do your your NTSCs and KVPI and your NSOs and ISOs. You guys are all very into all these kind of competitive exams. So how do you train yourself for that as well? And apart from that, choice of your own schedule, because obviously that is a very big problem, because you're not free when the teacher is free. When the teacher is free, you're not free. So the choice of schedule is also a very important issue. And finally, guys, choice of your own language. How do I study in the language that I feel comfortable in? Now here's the thing, guys. These are all the problem statements that you guys have to list. Now I'm pretty sure that you guys will be able to relate to this. Now you'll have a lot more to add on to this, but these are some of the basic stuff. Now here's the thing, guys. We at Vedantu have solved all of these problems. How do we do so? In the class, you will not just have one teacher. Instead or rather you will have two teachers. You will have the master teacher and the class teacher as well to help you clear your doubts. So you get personalized attention, making sure that your doubts are cleared on time. You get unlimited notes. I mean, whatever notes are there on the Wavebook, you can download it and read it how many number of times you want. You'll get the recordings of each and every session. So even if you miss out a class, you can always watch the recordings. You'll have regular tests and assignments to check where you're going wrong and what are the things that you have to do to improve yourself. Competitive exam, you'll be trained for your competitive exams as well. You can choose your own schedule, whatever time you feel is comfortable. You can choose that time and study the concepts. And finally, guys, choice of your own language. You will not just you'll not be forced to study in English. If you want, you can also study in Hindi as well. So we are offering classes in both English and Hindi. Regional languages for now is not an option, but in the future we might be adding that as well. So here's the thing, guys, apart from all of these, that's not it. You'll also be getting unlimited live classes. You want to attend 20 classes in a day, go ahead, guys. Like the quote in the start of the class, you're the ones who are going to build the wall around you. So as long as whatever is the extent of your wall, you can study how much ever you want. There's no limit to it whatsoever. You have unlimited micro courses and crash courses. You get detailed performance report card and personalized attention, like I told you in the case of the master teacher as well as the class teacher. So here's the thing, guys, what you have to do is click on the link that is there in the description below. Once you click on that description, this is what you're going to get. They'll ask you which grade are you in. Are you in first grade or to 12th grade? Let's say that you are someone in 10th grade. Once you click on it, they'll ask you which board are you do you belong to. Are you from CBSE, ICSE or Maharashtra board? For now, we are only offering classes in these three syllabuses, but yes, in the future we'll be adding more to that as well. Let's say that you go with the CBSE syllabus. Once you click on it, this is what you're gonna get. You can just pause the video and check out all the details, because yes, whatever I've just told you, everything is written right here. Now what you have to do is basically click on get subscription. Once you click on get subscription, this is what you're gonna get: 1, 3 and 6 months. So what exactly is this pro subscription course? Let me just tell you this, guys. Like I told you, pro subscription is the place where you get you have the best of the best teachers with unlimited doubt solving and everything that I just told you. So what you have to do is very simple, guys. Let's say that you want to try the 1 month course. You want to try it for the next 30 days. So the base price of that is 4,000 rupees. But don't worry, you'll not be paying so much. You'll get a primary discount, and essentially you'll be paying just 699 rupees. But if you click on this enter coupon code and enter the coupon code AM Pro, you'll get additional 500 rupees discount. Essentially what you'll be paying is 2,159 rupees. Let's say that you want to go for the 3-month subscription course. So the 3-month subscription course, the base price is 10,000 rupees, but don't worry, again, you get a primary discount on that. So essentially the price is 6,999 rupees. Again, if you enter the coupon code, click enter coupon code and enter the coupon code AM Pro. Do not forget this. If you enter that coupon code, you get additional 1,399 rupees discount, and you'll be paying the amount of 5,599 rupees. Let's say you go for the 6-month course. For the 6-month course, the base price is 16,000 rupees. You get an additional discount on that. Don't worry about it. You'll be paying 11,499 rupees for 6 months. But again, if you use the coupon code AM Pro, you'll get additional 2,299 rupees discount. And what you'll be paying for the next 6 months would be just 9,199 rupees. Now, here's the thing, guys. Trust me, you'd find this definitely, for sure you'll find this very, very helpful. Try out the link. Once again, the link is there in the subscription, in the description below, and the coupon code is AM Pro. So check it out and let me know what you think about it in the comment section below. Thank you for joining. Thank you for, listening to me for that, guys. With that, so here's the first question, guys. The question is this: when a ray of light passes from glass to air, the speed of light increases, decreases, remains the same, or can't say at all? What do you think is the right answer? Let me know what is the answer in the comment section below. The answer, guys. The ray of light is passing from glass to air, from a rarer medium to a denser medium. Sorry, from a denser medium to a rarer medium. So the speed of light would actually increase because it's going into a rarer medium. So the speed of light would actually increase. So it's not actually option number B, guys. It'll be option number A. It'll definitely increase. From glass to air, it would actually increase. Second question: light is slower in glass than in water. If light travels from water to glass, it turns towards the normal. Away from the normal, it won't bend at all, or can't say. So light is slower in glass than in water. All right. So glass is definitely denser and water is definitely a rarer medium. So if light travels from water to glass, that is from a rarer medium to denser medium, what happens to the ray of light? The answer, guys, you know it. The answer is that it would bend towards the normal because it's moving from a rarer medium, from water into glass, so it will bend towards the normal. That is the answer. Third question is, what happens when light is incident on the normal? Would it reflect back? Would it pass undeviated? Would it refract? Or either A or C, that is reflects back or gets refracted? What do you think is the right answer? Comment section below. The answer, you know, guys, if it's passing through the normal, then it would pass undeviated. It'll pass straight through the, it'll not have any kind of deviation, and it'll pass straight through that glass slab. As simple as that. Fourth question is, refraction happens because water holds light rays. Water is fluid, so light bends. Speed of light changes in different medium, or none of these. What is the reason behind refraction? Comment section. The answer, guys, is definitely option number C. The speed of light definitely changes in different medium, and that's why refraction happens, because speed of light is different in different medium. The fifth question is actually homework. So let me know what is the answer in the comment section below. Again, the homework is this, guys. The incident ray and the emergent ray are dash to each other. Let me know what is the answer in the comment section below. I'll be expecting your answers pretty soon. Thank you for joining, guys. I hope you enjoyed today's session. I hope you learned something new today. So thank you for joining. Leave a thumbs up and like, share, and subscribe, and let us know what you think about how the sessions are going in the comment section below. Thank you for joining. See you all on the next one. Take care of yourselves. Stay safe, guys. Bye bye. Until then, take care of yourself. Bye bye.